Yeah, could you just shut that door? All right, so at this point of the program, I'm going to transition more into some of the AI applications piece, and I'm delighted to have with me two experts in health technology and analytics. One is Ray Christian, who's the founder and CEO of Textpert. They are leading applications converging AI in mental health support. The technology AiME is based upon clinical trials at UCLA, and recent findings have been published in the APA. And Christian, who's also ex-LA-based radio show host, interestingly enough, has been featured in a variety of outlets from Mashable to Sirius, PC Mag, Huffington Post, and so forth. He's also spoken at Singular University, Exponential Medicine, Health 2.0, and we're delighted he came here from San Diego to speak with us today about some of the amazing work that his company is doing. And then to Christian's right, Ray Christian's right, I have Prithvi Rao, who's Executive Architect for Federal Healthcare at IBM. So in this role, he supports IBM's CTO strategy across the federal government, working with DoD, HHS, a number of federal agencies on leveraging best-in-class advances in IT and analytics. And he's going to be speaking about some of their practical applications applying AI, conversational AI. So this is great. I think this is especially relevant when we think about sort of the prevalence of messaging apps. Now, if you look at the top 5 of the all-time top 10 used applications in the world, messaging apps make up five of those. And so in a world when we see mobile app use is declining 20% year on year, messaging app use is continuing to grow. I mean, each day, billions of people rely on messaging apps to communicate, to coordinate, and so forth. And now, especially with the younger generation, where messaging is becoming sort of expected of companies, and more so in the future of health organizations, to be able to provide instantaneous, quick feedback. This is a sort of big opportunity to meet patients and consumers where they are. When I think about the sort of the technical challenges of providing a natural language-based messaging application, if you look at the typical gap in a conversation is 200 milliseconds between interactions. And so if you think about within 200 milliseconds to replicate natural language, you have to sort of have an input, what the person is saying, and then sort of run multiple AI models to decide what's that best output, and then respond in a natural way, which is, and natural language is still sort of one of the most complex sort of forms of communication for computers to understand and process. And if you look across the U.S., one of the biggest sort of technical gadgetry that's being adopted, smart speakers. Amazon Echo, I think they have over 30 million shipments in the U.S. now. Google Home Mini, Microsoft's kind of catching up, but sort of these interactions that are moving us from having to type all day and get sore forearms, if you're like me, to have natural language speech interactions. There's probably going to be how we're communicating with systems in the future. So with that, let me invite Ray to talk a little bit about his work in this field, and then Prithvi will, and then we'll have time for questions from the moderator in the audience. So here we go.
So, I was a 20-year-old kid many years ago, and life was kind of going according to plan. And then I got sick with an autoimmune disorder. From there, I got really sick and had to drop out of school. The profound loneliness that came from months of recovery then led to depression. And from there, I developed a 10-year addiction to sleeping pills. And it turns out this story is a common one, this overlap of mental illness and addiction. And I look back and think, if there was some technology that could have warned me that I was at risk, that I was getting worse every day, I could have avoided a lot of pain. And same for a lot of other people. Thankfully, that technology is here today. But first, 3 takeaways for my presentation today. Number 1, this AI revolution is happening faster than most of us expect, and yes, AI can do anything that we can do. It's just a matter of time. Number 2, mental health is the next new frontier for the AI revolution. And number 3, that's a good thing because mental health care is healthcare. So when you're on an exponential curve, it's hard to know it until afterwards, when you can see in retrospect. So it's important to look at the patterns and signs. So if you look at AI now, we all see the gimmicky stuff. So AI is beating humans at AlphaGo, at chess. You see more useful stuff like driverless cars. You see AI vision technology, which is really about 10 years old, now beating doctors at cancer diagnosis. You have AI that's better at judging humans than judges. So it can predict who's going to skip bail and skip trial better. And then finally, you have things like AI composing symphonies and building artwork and paintings. So big change is coming. And mental health is the next step, especially with AI and more specifically with conversational AI. So the big question is, okay, well, if AI can do everything we can do, or we can all lose our jobs. Well, in the long term, maybe, but in the near term and the medium term, it's going to help. It's going to make the lives of those in the healthcare world easier. It's going to help make everybody else a little bit healthier. So it's a good thing. Because we got a couple big problems. One, mental illness costs America $467 billion a year. $504 billion is the opioid epidemic. And it turns out they are interrelated. So not only are they bidirectional, comorbid, but also causal. Turns out that mental illness is the #1 risk factor for addiction risk. It's almost a proxy for addiction risk. So, okay, what's our best tool for tracking this objectively and seeing what's happening? We got a couple. First one, the questionnaire. Well, unfortunately, they lack tone, they lack nuance, they're black and white. And of course, there's self-report bias. You might say, okay, well, what if we could see somebody in person? We're good, right? Well, every healthcare professional suffers from the same issue as every other human. Memories fade, bias from a bad day, inconsistent reporting language, we describe things a little bit differently from the next. But the biggest issue is there is way more demand for help and not enough supply. They can't do this by themselves. So that's why we created AiME. So a quick little tangent, our first attempt was a fully conversational AI therapist, and her name was Tevi. The problem became too difficult because of the problem of memory. So we ended up taking a step back, and that's when we created AiME. I'll give you a quick little demo of how she works.
Hi, I'm AiME. Just like you use a scale to check your weight, now you can use AI to check on your mind. I'm here to help you neutralize anxiety and create calm. Here's an example of how to work with me.
It's been kind of pretty well, but then it's like not as great as it usually is. And I feel like I've probably been drinking more coffee.
When we interact, just be yourself. Then I'll show you confidential AI-powered insights into your mind's health. After you complete your first question, you can skip the rest, and I'll share a little about me and why I was made. Okay, how have you been feeling lately?
And so from there, I would respond and start talking to AiME. So we lost our place. We're back. Okay, and so while I respond to AiME, as I'm talking to her on my phone, laptop, and you don't need an app to do this, she observes 3 key modalities: your facial expression, your tonality, and of course, the words that you use. And she looks at every nuance, and I mean everything. So pupil dilation, mouth mapping, eye activity, every word choice, every word pairing, and then she looks for the patterns. The end result after the deep learning neural network is done processing is this. You've got a HIPAA-compliant, secure, confidential report on your mental health with objectivity, precision, and nuance. So you can finally track how your mind is doing over time. So how does this work? So just like a doctor uses her eyes to see you, AiME uses the webcam. And what you see here is the many ways in which AiME sees just a single frame. So there's on average about 8 frames per second. We use tools like ResNet, data augmentation to filter out the noise, find the signal, and from there, AiME looks for patterns. Up next, just like a doctor uses his ears to hear you, AiME uses the mic, and what you see here is a single sentence digitized for inflection variants. AiME looks for the patterns. And then finally, word choice. What you see here with the red bubbles and the blue bubbles are positive and negative sentiment words. And on the right, to interpret meaning, we look at every single word, and what you see on that graph on the right is, again, a single sentence digitized across 100 dimensions and scored. And again, she looks for patterns. Here's where it all comes together. You have an ensemble neural network after the data runs through many hidden layers and nodes. These neural networks are then stacked on each other for the purpose of a prediction on mental illness. The performance of late, we're at 80% accuracy, 90% precision specificity after our 750-person trial. And the results of that turned into a paper that was just published with the APA. And what you see on the right is a rock curve. The middle line is chance, and you can see how much better we are, how much better AiME is above chance. So to be clear, what we're talking about here is an AI that can watch you speak extemporaneously for 30 seconds and then predict your mental illness. A couple of fun insights. This is the 3D model of every word that was used from the users and people that were part of the trial. But 2 fun takeaways we had. Number 1, the depressed individuals, they responded on average way longer than non-depressed individuals. And yet, they used much less word variability. So they're repeating words over and over. And the second interesting finding, there was one word in particular that they tended to use way more than non-depressed individuals. And it's the word really. Really sad, it's really hard, really difficult. So if we truly want to get from reactive to preventative healthcare, ultimately we have to address the mind. Otherwise, it's just a game of whack-a-mole. Dr. Franz Alexander had a quote, famous physician, psychiatrist, said, "The fact that the mind rules the body, despite the neglect of biology and medicine, is the single most fundamental fact we know about life." And Kaiser found this to be true. They looked at the study when people came in for bodily issues, physical issues, and they had them do just a little bit of mental health treatment, just talk to somebody for a little bit, the cost went down by half. Torrance Memorial Hospital in LA, where I'm from, said the same thing, by 40%. Just a little bit of mental health treatment. So we have this opportunity. Mental health has kind of been the redheaded stepchild, if you will, for a long time, and it makes sense because it's been so hard to track objectively. It's no longer the case, though. We have a couple quick so whats for our team at Textpert. So what do we do with this cool information? We got to get people to use this technology. And there's 3 things: curiosity, creativity, and calm. So first, allow people for the first time to really quench their curiosity on what is happening in my mind. How is my mind's health? What's working, what isn't? Number 2, creativity. Start to create that future you with these video messages. It's kind of like a Matthew McConaughey Interstellar bookshelf type deal. Leave a message for future you that might be having a bad day. Are you having a tough time? Go look at a past message where you reminded yourself of your accomplishments and some of the good things that you've been doing lately. And then finally, simply talking out loud can be therapeutic. When you get your challenges out, it makes them feel much less like this thing inside you that's poisoning you, that is you. and much more like something outside of you. It's more like a riddle to be solved. So, the three takeaways. AI can do anything we can do, and it's happening fast, but that's a good thing because mental health is that next frontier for AI, and that's a really good thing because mental health care is healthcare. And if I could go talk to the 20-year-old kid that was having a tough time and tell him, hey, you're at risk, watch out, you're trending in a bad spot, maybe I could have avoided a lot of pain. But fast forward years later, I was able to take that depression, wrestle it to submission, and hadn't used a sleeping pill in 6 years. So maybe some of us have to suffer so others don't. But my question to you as I wrap up is, in a world where we have AI capabilities that are way ahead of schedule, what does success look like for you? Thank you.
Thank you, Ray. I mean, it is striking how much the mental health needs of the population are growing, or if not growing, they're getting more attention. There was a Nature article that came out within the last week that said almost 36% of PhD students have sought some help for anxiety and depression. And we all know how busy PhD students are, so we can find easier ways to get that help. It might be a benefit. So let me turn it over to Prithvi Rao.
Thank you. Thanks, Ritu and Kenyon, for the invite. Appreciate that. I'm from IBM.
Use the microphone?
Oh,
Thanks.
I might sit down first.
No, she has a microphone.
Test. Test.
Thank you. So I'm from IBM. Like I mentioned, I work across Veterans Affairs, Military Health, and Health and Human Services. And Ray mentioned about the mental illness. And we, in fact, have an AI tool, conversational AI, for suicide prevention. It's called the GRIT, G-R-I-T, and we're working with the Veterans Affairs on that enablement. But I'm not going to talk about that today. Today I'm going to talk about the conversational AI, and many of you know what this is all about. You've been used to using Amazon Alexa, the Apple Siri, or the Microsoft Cortana, or something of that nature, asking it some basic questions like, what's the weather like, read me the news, or order me a pizza. And it's a very good virtual assistant. It does a lot of good things. And then sometimes when you order a pizza, it knows what credit card you have to use. So it's smart in a way. But what IBM is doing is, in this space, we wanted to see where we can take it a little further. Instead of being just rule-based, we wanted to be more machine learning and the ability to learn as we go. So in that mode, I wanted to talk about today what we have done from a health benefits plan perspective. So when you all have health plans, and how many of you really look at all the details that there is out there? You don't really look at anything, right? So hardly, it's 1%.
I just saw 1%.
So it's very complex, it's very time consuming. Unless you are really focused on something, you really go down that path. So that's a challenge that we have most. And many times, you have this call center people in healthcare plans being called and asked some basic questions. What is a formulary? What is my insurance? What is my documents? What documents do I need to fill in? What am I eligible for? Is this procedure I'm able to apply for? So those kinds of questions keep cropping up all the time. And that's a big challenge. And what happens with the call centers? And what happens with the call center is they're getting bogged down and the information is not in one particular place. So we found on our research, each call costs the call center about $4 to $6 per person when we handle them. So it's really a lot of disconnect, a lot of time consuming nature of these call presentations. So we have a lot of challenges and we wanted to see how we can bring this all together much more seamlessly and make it transparent to the end user when they call in. So this is a challenge that we have in the industry. Users, as you all know, want responses and very quickly. They're no longer waiting. They don't have the patience. We have found out that it costs almost about $62 billion when we don't have this call centers properly managed. And 81% of the people turn over if they get a bad relationship with the call center. They don't like to wait to get their answers. They want instantaneous responses. So what can we do to help them in that case? So we have scenarios where they call in, the call center agent has to go through where is this patient or is eligible. They have to find that out. They have to go to different claims databases. They have to go to benefits databases. There's a lot of information that they have to collect before they can give a comprehensive answer back to the member who's calling in. This is a challenge. And they spend a lot of time, high frequency calls for low value. When I say value, it is these information can be easily gathered and presented back to the user if we have some kind of a mechanism in the background which collects all this information and makes it available easily to the end user with a simple Q&A format. So this is where we come in. We have come up with Watson Assistant for Health Benefits. So it's basically an AI system which has the ability to go and look into your back-end enterprise data systems, and then based on the conversation it has with the member, zero down quickly to the answers specific to his needs and respond back to that. So we wanted to do this and transform the member experience as well as improve the call center performance and reduce the cost overheads. It's very expensive for even the call center members because they get burnt out, and to train them back and bring them in place is very expensive and time-consuming. So these are some of the basic expectations. I mean, you can't read them. It's basically when the member calls in, they want information, what are the benefits that they're eligible for, and what is my copay, how much am I required to pay, and am I eligible for this procedure, and things like that. And then the call center agent has the need to quickly gather information, consolidate it, aggregate it, and then provide answers. And the third one, providers. When patients walk into a doctor's office, the doctor needs to know, what is this patient eligible for? Can I recommend a certain procedure or a treatment plan? And if he has that information up front, he can guide the patient in a much more productive fashion. So he has that ability. And finally, the call center. We have all this data that's collected. So can we run analytics? Can we find out what is the sentiment of the population that's calling in? Are we able to deflect calls to low volume ways of responding without an agent in between? So these are some of the factors that we would like to do this. And the health benefits that we have, this is an offering that we make available, and we have gathered. It's already pre-built. That means we have machine learned it, we have trained it, we have pre-configured it for the health benefits, so that we know what the intents are. An intent could be, am I eligible? And then what are the different entities? Am I eligible for MRI? Am I eligible for a knee surgery? So all those kinds of things we have already gathered. So, and we have built this one, so you don't have to start from scratch. You can use this and jumpstart your application and connect it to your endpoints. It could be a mobile application, it could be a Facebook Messenger application, it could be anything that you want to connect it to. So we have this capability to do that. So I'd like to walk you through a quick demo of what this is. So we have a situation here. You see the screen there? So we have a situation where Jack, he's been struggling with.
Don't see the screen.
You don't see the screen?
Everyone stare into the sunset.
I had it before. Now these things happen, so let's cancel out. So what I have here is
It's up.
yeah. This is now. I'm not going through the demo now. I'm just going through a backup plan. Yeah. Here we have a scenario. John has been struggling with knee pain. He calls in. He has his he has a silver lining healthcare benefits plan. So he comes in, he logs in, it automatically brings up all the information about his benefits, and it tells him how much he spent on his copay, on all the expenditures and stuff like that. So he has been struggling with knee pain and he wants to have a knee surgery. So he wants to go in and click on this icon. This is the Watson Assistant icon. So it comes back and says, hello Jack, I'm a cognitive healthcare system. What do you want to do? What is your requirements? And Jack says, am I eligible for knee surgery? That is the question that he asks. That's the one that you see in green. And the system in the background instantaneously goes and collects all the information and says, yes, you are eligible for knee surgery, but you have to get pre-qualified and you have to call this number. So it makes it much easier and for him to say, yes, am I eligible or not. And the next step is, it asks him, it engages him in a natural conversation and asks him, would you like to know the costs of it? And he says, yes. And if he says yes, okay, cool, let's get started. It's again, very cognitive, talking in a natural language, communicating with the end user. So who do you want to perform the surgery? And he selects one doctor by name Pagano, and he happens to be in network. So that's good news, and the system confirms that this is the right doctor with the right address and information, and he says yes. And then it asks him, where do you want to have the surgery done? And he says, I want to have it done in the ETH orthopedic hospital. So, and again, this one happens to be in network, and the system comes back with a list of information, network status information. Yes, you are eligible for this because you are inside the network. This is going to cost you so much. And what is your out-of-pocket expenses? All that information is in great detail. It's been laid out. So it's very quickly and comprehensively, within 5 minutes, he's able to find out where his status is for knee surgery. How much is it going to cost him? How much his out-of-pocket expenses are? So it's very quick and easy, and he's very happy with these results. And he comes back and asks him, do you need anything more? And we also have not so happy path. What happens if he says, I don't have a doctor? It has the ability to bring that one up as well and show him a list of doctors available in this network area, and he can select which one of those he would be happy to have a surgery with. So those are the different options we have available, and you can tune it to any way that you like it. And we can tailor it to claims data. Right now it's only for surgery, but we can go to claims data to see what the status of the claim is, and so on and so forth. It becomes very, very powerful and easy to use. So that's basically the end of the demo, and I'll let it back to you.
All right, thank you, Prithvi. All right, so I'm going to ask one question. We'll have time for one or two questions before we break for lunch. So in this room of academics, so what do you think are some of the one or two key research questions about conversational AI that need to be answered? Because you have potentially people here that can answer them.
What's it again? What was the question?
What are one or two key research questions? Key research questions about conversational AI that needs to be answered to move the field forward.
Moving forward, research questions is good question.
I can give him a break.
Yeah.
You just talk for a while. So for us, it's the reason we had to stop building Tevi, which was the predecessor to AiME, was because memory was too much of a challenge. So we got Tevi talking, it was novel. We don't know why she said some of the things she said. It was grammatically correct. It was often enough relevant, but her memory was non-existent. So she couldn't remember that a minute ago we talked about the lack of sleep or the stress at home. And so the memory problem is really going to be crucial to be truly conversational. Otherwise, it's kind of a parlor trick to pretend like you're in a conversation without good memory of knowing global memory about the world and also specific memory about this patient.
Mm-hmm.
It's going to be tough to truly get conversational.
Mm-hmm.
Okay.
So, Doctor.
Yes, Rita.
So I want to roll the clock back 30 years, and I'm reminded of Eliza. Some of you who've been in AI for a while will remember Eliza. And I'm just curious for both of you, have you subject your systems to any kind of Turing test? Just put them face to face with a mental health professional or with a group of mental health professionals and just gotten a sense for how people are responding to these technologies? Or, in your case, a call center expert?
Yes, we from the VA, the GRIT application, yes, so we have a hotline for the veterans to call in for PTSD syndromes, and based on the tonality of the voice, we can find out, is he more susceptible for committing suicide? Do we bring in interventions quickly enough? Yes, we have had this, and the VA is very, very happy with the project, and we are working with them for further enhancements. We have also teamed up with another company called Vision 360. So total health 360 as well. So they come in with their AI, and we collaborate together to make this a much more high touch kind of, so that the patients are immediately addressed with the challenges that they have. So we do that from our perspective.
So we decided to not go that route because it's so difficult to truly emulate a conversation. There are Turing tests and there's competitions. A really good book is The Most Human, but it's kind of trickery. It's a little bit of smoke and mirrors to pretend like you're in a conversation with certain rhetorical mechanisms or changing the subject, and you trick the person into thinking, wow, I'm actually talking with a human. So that's why it's such a complicated problem, because of the memory problem. And the more you dive into memory, the more you actually start playing around with this overlap, this Venn diagram with memory and consciousness. And we're quite far away from solving that problem, the consciousness and memory problem. So that's why for us, we decided, let's avoid true AI conversation just yet, and instead do AI classification, meaning let's watch people talk, and not just what they type, not just what they say, but also the tonality and their body language. And obviously in communication, that's a huge part of it.
Yes, Dr. Resnick.
This is great, both of them, and thank you. The quote, mental health care is healthcare, keep saying that. It's really important. The quote, AI can do anything we can do, stop saying that. Speaking as an AI researcher and entrepreneur over a long period of time, I've spent a lot of time spending time trying to reduce the expectations that are created by hype. And the expectations that get set. IBM itself ran into some of these problems with expectations that were set, with Watson being so amazing in some contexts and difficulty translating into other contexts. So I think looking realistically at what we can do, what you just said was exactly right? There's deeper levels of analysis for language we don't know how to do yet. People are working on them. But the crucial point, and the one that you emphasized, I think is great and really important, is there are things we can do now with classifiers. But to follow up on that question, so there's actually a question, not just a comment. Have you looked, the ROC curve is great for intrinsic evaluation of classification. In this case, I assume it was suppression. Have you looked at extrinsic evaluation, i.e. outcomes, for people who are actually using the technology? Do you have any measures yet, and it may just be work in progress, of the actual effects on the human beings who are using this in terms of the baseline versus what happens after they've done the interaction?
So, I like what you did there, by the way. You gave me a compliment and then a dig after that. I appreciate that. So I would take issue with that just because I I think if we came from rocks and chemical properties, and now we have this consciousness and where we are now, AI with silicone and hardware and software eventually can get there. It's going to be a while though. So that would be my take on that. And for the record, I'm terrified about AI in the long term. So to your question about the actual application and watching people getting better, we are seeing people get better with their repeat talks and conversations, but that data is still, the jury is out. So we're on a clinical trial right now for that, but shoot me an email sometime and I'll keep you updated.
Absolutely, keep doing it. Thank you.
I'll just add to what he just said. I agree with most of what he said. I would say that AI is not going to replace the human being. We are going to be only augmenting the human intelligence. So we're not saying AI is going to be a replacement. It's no way that's going to happen. Especially in the healthcare field, there's a lot of liabilities involved. So we have to be extremely careful what AI can do for you. So it's always the doctor is in between, or some kind of a middleman is there, taking the AI that comes in and then massaging that information and producing it back to them. So certain small things like the finding of the benefits plan and all that stuff, doing the NLP in the background, those kinds of things can be done with AI, and it reduces the burden of work. But major decisions, healthcare decisions, will have to be done by the doctor, and AI is only going to augment that.
Any final questions? One last question. Yes.
Thank you very much, for your talk to us. I'm from Penn State. We do research about mental health too. I want to ask you, text expert. I actually got your website and to see how it looks like. My first question is how you design AiME. She looks like middle-aged, wear glasses there. That's one thing. And another thing we know is very crucial is the loyalty. How many people will come back to your website and keep using it, and you can have more data there. So basically, the two questions are for you. Thank you.
So thank you. The first question about how did we design AiME, it was a simple question, which is, what is the most disarming demographic? And for us, we thought it was a 34-year-old woman. And it seems to be a little bit easier to open up to a woman than it is a guy, and so that really, for us, made that an easy choice. And then the second question about loyalty, that is probably the most important part of this concept of applying technology. So in the past panel, someone mentioned all these papers that were written and then trying to figure out how to use it. It's almost just as hard as figuring out the technology, is getting people to use it and then use it consistently. And it's actually our #1 focus right now. So I would describe our loyalty as good, getting better, but room for improvement.
Okay. Well, thank you both for being at the cost of leading these initiatives, and thank you all for your attention and good questions. And with that, I'd like to break the session and welcome everybody to have lunch right outside here. There'll be a buffet, and you can bring your food back in.